All right, let's start the class then. Fine. So before we left in the previous class, you asked me about how we can create an array for a structure, and that's exactly what I'm going to teach you today. So we had seen that this was the last thing that I had told you. I just started with this array for a structure, but then the class, ended. So I'm going to continue with this today. So if you look at the statement here, right, I have written a structure that's struct, that's a keyword which is used to declare the variables as well as define a structure. Test is the name of my structure, and T1 is basically the variable, the structure variable, right? So this is a single structure variable. So T1 is a single structure variable. However, if you want to create an array of a structure, for example, in the second instance here, I've created an array which is like student with how many elements? 10 elements. So this 10 elements is going to be arranged in a manner which is shown below. So we are going to have 10 different memory locations, right? And in this 10 different memory locations, you are going to store the different structure elements. Okay, now this works with an array because structure elements are taken as a homogeneous data type because all of them belong to the same data type, which is the test structure. Okay, and what is going to be the size of each element? So if we are talking about a structure which has got, like, say, one integer, one float, and one character. So if this integer has 4 bytes, float, say, stores 8 bytes, and character has 1 byte of memory, which is allocated to this, then in all, the minimum size that a structure requires is going to be 13 bytes. So this one block of an array, okay, so let me just show you. Okay, so this one block of an array is going to be minimum of 13 bytes. Okay, now it could be a little more because I told you it's compiler specific, because compiler uses some extra bytes of memory to manage the padding. That means to keep the spacing between two memory locations so that the values don't intermingle with each other. So this is another memory location, which is going to be of 13 bytes, another 13 bytes, another 13 bytes. And inside this 13 bytes, we are going to have, so inside this 13 bytes, we're going to have three separate memory locations, one for 4 byte, 8 byte, and 1 byte. So this is how the memory is managed for a structure array, or a array which contains a structure. Now, just to make things more simple, as in, like, how does it actually work when you write a program? I can show a small program and kind of demonstrate it as well. So just let me write a simple small program, just to manage a structure and sorry, an array of structures. Okay, so let me just write here so that uh, you can follow it well. So I'm writing my standard hash include stdio.h. If you want, I can also send you this program, but it'll be nice if you can write it yourself because I'm already showing you how to do it. So let's declare a structure. So here is my structure, which I am defining. So let's say, since we have used student in the last example, let me use a structure called as student. Now I need to define this. So I am going to add three things. So let me add a roll number. So this is going to be one data type. Second thing, let's add a grade, right? Now grade is also called as CGPA. That means this is your total percentage. CGPA means cumulative grade per average. So basically, this is how we calculate your percentage in KIIT. And the third is, let's say we add a character, which is gender, right? So these are the three attributes or data types that we have defined in a structure. So what we need to do, close it. Okay, so this part is good. Now our structure is ready. So we have already defined the structure. Now let's write a program and see how we can create an array of this. Okay, that's the whole objective of writing this program. So I start with my int main method, right? So here's my int main method. And then I start with my my main method, and inside this main method declare an array, then I need to loop through that. And in order to loop through that, I need a for loop, and I need to run the for loop using this variable I. So now I am going to declare a structure array. Now this step is going to be important because this is the main focus of this problem. So how do I declare a structure variable? So I use a struct keyword, right? So I'm going to declare an array. So what's my structure? Sorry, my structure name is student. That's what I have defined above. So I need to write student. Okay, this is the type of data type which I've created, which is a student structure. Now I need to declare an array. So let's say BCA or BSc, anything we can write. So let's say BCA. Okay, we are creating an array of 10 BCA students. Okay, we are creating an array of a structure which will contain the roll number, CGPA, and character, the gender of 10 BCA students. You can change this to MCA. You can change. Let's write it MCA because we have BSc and BCA students here. So should not feel offended that I'm using only BCA. Okay, here are my 10 MCA students. Okay, so this is basically a declaration of a structure array. Okay, what type of array is this? It's a structure array. What is the name of that structure? It's student, and I have 10 MCA students whose information I can put it into a structure. So what's going to happen here is roll number 4 bytes, floating point number 8 bytes, character 1 byte. So total 8 plus 4, 12 plus 1, 13 bytes. So I need 13 bytes of memory for each of these array elements. So what's going to happen in the memory location? I'm going to have 10 compartments, consecutive memory location, and each one of them having 13 bytes or more. Okay, so this is how this memory is going to be allocated when I write this particular statement here. Okay, any questions on this so far? Just give me a quick response.
No, sir.
Okay, great. So let's move ahead and see how we can actually access the elements of a structure. This is simple. Now, let's enter the details of all the students. So I'm not writing the printf statement, which is basically going to ask, to enter the details of the students. But what I'm going to do is I'm going to write the for loop now, right? So let's change the color of this to black. Okay. Fine. So let's write the for loop. So here is for I is equal to 0, I is less than 10, and I plus plus. This is elementary for you now because you've already done this before. So let's enter all the details of 10 students. Now the point here is, how do I access the details of 10 students? So let's say I have MCA, and MCA 0 is going to point to the first memory location, right? It's going to point to the first memory location. Inside this, there are 3 variables: roll number, CGPA, and gender. So how can I access the roll number? So if I need to access the roll number, I will write dot roll underscore number. In order to access the CGPA for the first element, I need to have something like MCA0 dot CGPA. Okay. In order to access the gender, I need to have MCA0 because this is an array. So it's going to point to the first element of an array, and I can write gender. So this is how I can access the 3 different memory locations inside the array memory location. Okay, so when I write MCA0, it points to the big cell. That means the memory which is allocated by that array. And then when I do dot roll number, it's basically pointing to the first element of the structure inside that array. I hope you're understanding this. When I write dot CGPA, it's going to point to the second element inside that array, inside that structure, and gender is going to point to the third element inside that structure, which is pointing basically which we are accessing. We are accessing the first element of this array. So inside the first element of the array, I have 3 elements of the structure, and I can access this way. So if I want to access the 3 elements of this second memory location of an array, I need to do MCA1, MCA1, MCA1. Okay, so this is how I can access the elements of an array. So if I want to, if I want to take the data from the user, right, and initialize the array, initialize the structure variables with that data, then what I need to do, I need to write a scanf, and all of you know this, right? So we use scanf, Now I need to enter three data. So I need to enter a decimal, a floating point number, and a character here. So I have to use format specifiers %d, %f, and %c, right? This is fine. Now I need to basically access the memory of, you know, the first array element and the roll number element of the structure. So how can I access? So I will write MCA, right? And I'm going to give the value I here, right? We know how to do that. And now I'm going to do dot roll number, right? Roll underscore number. Now this is going to basically access the first element of a structure in the array element MCA I. And you know that when you're using scanf, you have to use the address of operator because we are going to access the memory location where this value is going to be initialized. Similarly, this becomes the first element of a structure. So if you want the second element of a structure, after the comma, I need to do MCA, and then you need to write I dot CGPA, and this is accessing the second element of a structure in the first array element. And again, we go MCA I dot gender, right? So you can take all these details from the screen, and here is my line of code, which is basically initializing the value of all the array elements, all the structure elements which is present inside an array. Okay, so these two line of code will actually initialize all the value. Now, if you have to print it back or if you have to access it, how will you do it? Simple as that. You run a loop once again, just like how we do it in any array, right? And inside that, you can access it. How do you access it? So in this case, I will be accessing it like mca.I, because if you have another for loop which is running, and inside this, I can use printf or whatever and access it as mca.I. Sorry, not dot is not going to be here, right? It's going
It's
to be
MCI dot.
MCI dot, you can have whatever you want, roll number, then roll number. Okay, if you want gender, then same thing, MCAI dot gender. Did you get this?
Yes, sir.
Okay,
Yes,
so
sir.
this is how basically you can, I'll give you this program for those people who are learning programming for the first time, you're finding it difficult to understand this. I'll give you this program, you can go through it again. I'll write it and send it to you as a doc file, and you can go through it, write it down, try to execute this on your computer, and then you will get a complete clarity on the structures as well as how we can create an array of structures. Okay. Now there is another concept which is very similar to a structure. Okay, it's very similar to a structure, but it is called as unions. All right, it is called as unions. 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 Okay, now structures and unions are taught together. So whenever you learn structures, you know, unions also you have to learn along with it. So structures and unions have a, you know, a lot of things which are common to each other, but there is a huge difference in the way things work out. So what's a union? A union is once again a very special user-defined data type which is available in C that allows you to store different data types in the same memory location. Now that's where things are different. Same memory location. Now let me explain this. Like a structure, you can initialize different data types, right, in a union. So let's first look at a structure and then we will come back and see how unions differ from a structure. In a structure, when I define a structure and when I define the different data types inside a structure, for example, integer, float, or I can also have char, or I can have a character array, whatever it is, you know, these values are allotted or allocated in memory location, and they are separate memory location. That means each one of them have got a reserve, you know, reserve memory location. That means integer value can come here. They have a separate room. It's a separate room. You have a floating point number, which is again a separate room, right? And you have a character, which is again a separate room. And if it's an array, then you can write, if it's a character array of 10, then you can write hello. Okay, so each of the structure elements are allocated into separate memory locations, in a continuous or a continuous memory location, but they are given their own space. That means they have a reserved memory location. All right, now what is the difference of a union? Now unions also can be defined to contain different data types. So union can also have like same thing as integer, floating point, and character. However, the difference between union and structure is that in a union you don't have this separate reserved memory location. So how are the memory location organized in a union? In a union, what is going to happen is, so if I declare the same example as a union, it is going to find out the memory location of each. For example, integer is holding 4 bytes. This floating point holds 8 bytes. This character is an array which is of size 10. That means a character array of size 10 will need how many memory locations minimum? It will need 10 bytes. So what the union is going to do is, it is going to allot a single memory location. It's not going to partition into reserve. So there's no reserve, spaces like how we had it for a structure here, but it's going to create one single block of memory location. And it is going to decide the size of this based on the largest size of your what you call the union element. So in this example, our largest size is the size of this character array, which is 10 bytes. So the size of this memory location, which is going to be allocated by a union, is going to be 10 bytes. Okay, what is going to be the size of this structure element if you find out the total size of the structure element? So in this, the total size would be integer is 4 bytes, floating point is 8 bytes, and character is 10 bytes. So the size of the memory location of a structure in this case would be 22 bytes. But in case of a union, it's going to be only 10 bytes. That means it's going to take the size of the largest element of the union. And in such a, why does it choose the largest element? Because all the other elements can also fit into that largest one. So if I take the largest element, integer can also fit into it, the floating point number can also fit into it, and this largest, that is character array, can also fit into it. Okay, so far did you understand what is the difference? Because I'm going to explain things further, but did you understand what I am trying to say here?
Yes, sir, clear.
Yes, okay, I'm going to continue here. So the only difference between a structure and a union is this, okay, in terms of how memory is allocated behind the scene. Other than that, is there any difference between structure and union? Yes, there is. Because if I have a single memory location and if I have multiple memory location here, then there is going to be some kind of difference, right? There's going to be some difference in the way my program is going to work, right? And that I need to worry about, and I need to see that how is the program going to be different in this case. So let's try and look at this from the difference in the way how the program is going to behave. Now, first important thing, how do you declare a structure and how do you declare a union? So you declare a structure by using the struct keyword, right? And then you write student, and then you start defining your structure. So let me just define the roll number, right? And we had a CGPA, right? So let's write CGPA, and we had character as gender. So this is how you define a structure, right? And how do I create a structure variable? So I need to use, in the main, I write struct student S1. All right, so this is the way I declare a structure variable. Now, if I don't want to declare a structure variable here, I can, straight away at the time of definition also, I can declare a structure variable. So if I don't want to write this line, what I need to do is I can write S1 here and close it. Okay, when I define the structure, at that point itself, I can also declare a structure variable. So either you can do this, or you can write S1 here and don't write this line. Both mean the same. Okay, so assuming that we are declaring the structure variable in our main method. So what do we do here? So in this case, we will close the structure definition here, and in my main method, I am going to create the structure variable in this manner. That's fine. Now, in case of a union, what do I need to do? In case of a union, everything's going to be the same, right? But in place of the structure, you need to write union. Okay, and in place of the structure, you need to write union. And other than this, everything remains the same, right? So how do you access the elements of a structure? You access the elements of a structure by writing s1 dot roll number, right? Or s1 dot cgpa, or s1 dot gender. This is how you access the elements of a structure. Similarly, for union also, you need to access the structure, the union this way. No difference at all. If you are using a pointer variable, then I told you that pointer variable needs to be accessed using an arrow. Same case, even in a union, you need to use an arrow. So other than, this keyword struct and union, there is no difference in the way you write the syntax in a program. However, there is a difference in the way the program behaves, and let's discuss that. Okay, in case of a structure, what happens? We have a single memory location. In case of a union, we have a single memory location. In case of a structure, we have reserved memory location. Okay, so this is your structure, and this is your union. All right, now let's say I have three data, which is my integer, that's my roll number, my CGPA is 9.2, and my gender is male. Okay. However, now in union, I cannot store all the three values at the same time, because there is only one memory location which is, available. So what I need to do in a union is I need to, share this. So at a time, either 5 can stay here, or 9.2 can stay here, or M can stay here. What does it mean? It means that I cannot store 5, 9.2, and M, all the three values in the memory at the same time. Now that's a huge difference. Okay, now what is going to happen if I actually, run the program and see? So let me just, show you a small difference. So if I actually need to use this value 5, I can store that value 5 in a union, use that value and forget about it. And then I need to bring 9.2 and use that value and again forget about it. And then I can bring M in a union and then, use that and forget about it. That means I cannot store the value in a union, all the three values, and use them later on. That's the difference between a structure and a union. So let me just give you an example. So if I have a union, say the name of my union is data, let's say just an example, because I have declared it as union data, right? And let's say I have two values or three values here. One is int I, the other one can be a float f, and the third one is character str, let's say 20. Okay, now if this is my union, right, and in the main, if I declare union data as d1, right, this is my structure variable, this is what I have done it in the main. Now I can initialize this d1, right? So I can initialize d1 dot I is equal to 10, and I can initialize d1 dot f, which is my floating point number, as 20.5, right? And I can take this character. So the easiest way to put things into a character is by and use a string copy. I have taught what string copy is, right? So strcpy. So I can take this d1 dot str, and in this I'm going to have hello. All right. So what happens is all my three variables have been initialized now. I hope everybody's understanding what I'm writing here. Can you just give me a quick response if you are understanding, or if you're not?
So can you repeat?
Yes, sir.
Continue. Okay, repeat. So what I'm doing here is I'm just going to repeat this. What I'm going to do is I've defined a structure here. I've defined a union. I'm sorry. I have defined a union here. Okay. And in this union, I have declared three elements. One is an integer, one is a floating point number, and the other one is a string. It's a character array of 20 elements, right? And what I've done here is I have declared, now this is happening in the main method. I'm not writing the entire program because it will take a lot of time, but I'm just explaining this. So inside the main method, I have created a structure variable for this definition, and the structure variable name is D1. And what I'm doing is I'm initializing the values of the structure variable one by one. So first one, I initialize the value of I as 10, F as 20.5, and strcpy. String copy is basically a function. Now, if I need to use string copy, then which library file I need to include? I need to include string.h. This is just a revision, string.h. So once I use string.h, I can use strcpy, which is a function which will copy basically this hello into my str array. Okay. Now what's going to happen here? What's going to happen here? When I write these 3 lines of code, as soon as I write this first line, one memory location will be created. One memory location will be created. Of how many bytes? Maximum size is 20 bytes. So we will have a 20 bytes of memory location. So when I write the first line of code, this 10 is going to be initialized into that memory location. Okay? All good here. As soon as I write the second line of code here, right, which is initializing the floating point number, what is going to happen is this 10 is going to be removed, and what is going to be, put into memory is 20.5f, right? And now when I'm actually putting the string inside this particular, array, then this will also disappear. And finally, at the end of that line, what I'm going to have is basically a string which is going to say hello. That's what is there. So the end of this line, I have a memory location where the first variable which I've initialized is lost. The second variable which I've initialized is lost. I have only the third variable, which is a string hello, which exists in the memory. Okay, so in this program, if I try to print, so after this, if I write this line, printf, and if I'm trying to print, say, %d, and I am actually writing, d1.I, I will not get the value 10 printed. There will be some garbage value which will be printed. Why? Because this 10 doesn't exist in the memory at all. Again, in the second line of code, if I write printf and I'm trying to print the value of f, again, it's going to give me a garbage value. It's not going to be 20.5. It's not going to give me 20.5 because it's going to give me a garbage value, because that doesn't exist in the memory. What exists is hello. And then if I want to print the third one, that means if I want to print data.str and I'm going to do %s, right, as a format specifier, what I'm going to get is hello, because this hello exists in the memory. Are you able to understand what's happening here?
Yes, sir.
Yes, sir.
So
just a question.
yes.
So what is the benefit of using union over structure?
Yes, sir. What is the
Or,
difference between union and structure?
Yeah, the benefit of using a union and the benefit of using a structure is, it's about what is your requirement. Again, if you're using a structure, then you can store the structure variables for, in the memory location, and you can use them whenever you want to. Okay, can you mute your microphones so that I can be more clear? Yeah, that's fine. So what I can do is, now let me just write a simple thing. So in this example, I can only access the memory location, which is basically the last one, which is initialized with the last value. But in case of a structure, if I write this program, then I will get all the 3 printed in a proper way. So I will get 10 printed, and I will get 20.5 printed, I'll get hello printed, because all the 3 elements are being stored in separate memory location and they are being reserved, right? But in case of a union, only the last one, the one which is basically being initialized the last, that is going to be used. Now the question here is, which one is more flexible? Of course, structure is more flexible. Structure is absolutely more flexible because, you can keep the variables there for a longer period of time, and whenever you want to use it one after the other, before you use all three together and everything works out fine. But union can be used if you have a memory crunch. That means you know that you are not going to use all the three variables at the same time. You're not going to use all the variables at the same time. Okay, that means your processing of the variables will be one by one. That means you don't need all the three values at the same time. So, but you will need one by one values. So in that case, what I'll do is I'll take the value into the structure, and then use that value, and then whatever has to be done. Then I take the second value, use that value, and whatever has to be done, I forget about it. And then I take the third value, put it into a union, and then use it, process it, and then I forget about it. So if I need all the values to be stored into a structure, and I need all the three values to be used at the same time, then I will need a structure. But if I have a requirement where I don't need to have all the three values at the same time, I can have one value, use it, have a second value, use it, third value, and use it. For example, if I initialize the value I here as 10, and here itself I do the operations on I, print I, and forget about it, then it works out. So if I write printf here, it will print 10. Then again, in the second line, if I write printf here after the second line, it will work. Then if I write printf after the third line, it will work. So if I don't need all the three values at the same time, then I can use a union. If I need all the values at the same time, then what I can use a structure. So the advantage of a structure is that I can store all the values and use it all three together whenever I want. What is the advantage of a union? Advantage of a union is, compared to structure, it uses very less memory. Okay, in this case we just saw, right? In this case, what will be the total bytes of a structure, of a union? It will be 20 bytes, because my character is 20 bytes, which is the largest. But in case of a structure, I will need 20 plus 8 plus 4. So that means 32 bytes of memory. Did you understand this?
Yes, sir.
Okay, so basically this is the only difference between a structure and a union. And I'm telling you that if you have understood this, simple concept, you are one of those very rare students who actually can differentiate between a structure and a union, and you know when to use a structure and when you use a union. There are many students who actually have done a lot of programming, but they don't understand this difference of structure and a union. You need to get into the memory. If you can visualize memory, if you can see, it's very easy to understand that if you have a single memory location where only one value can be stored at a single point of time, right? Then the behavior of a program will change. And how will it change? Right? You can easily figure out what's the behavior of a program in this case. Right? In a structure, 3 reserved memory location. I can use these variables whenever I want. I have the flexibility. Initialize them once and then use it whenever you want. After 10, 15, 20, 30 lines of code I want to use, I use it. After that, I need to use all of them together, use it. I need to take all the 3 and put it into an argument of a function, do it. But in case of a union, not possible. So when should the union be used? When my requirement is that I don't need to process all the data which is inside a union, together. One by one, if I have to process, I'll use a union. What is the advantage of using a union? A huge advantage of using a union is that I can, save a lot of memory. Memory allocations is only done as a single block, a block which can fit the largest element of a structure. Okay, so this is a very, very fine difference between a structure and a union, and a lot of students still, don't understand the difference between a structure and a union. So I hope you have understood this. And if you have a doubt, you can ask me right now. If you don't have a doubt, you can, kind of write a program on a structure and a union and see the output. You see how you can get a garbage value, In a lot of these interviews and all, they will ask you, why are you getting a garbage value? Okay, why you're not getting 10? Why you're not getting 20.5 in this case? It's very clear, because these values don't exist. So something or the other, some garbage value is getting printed, right? So you need to understand this really well. Please go back and revise this structure and union. It's a very delicate, difference. Usage is the same. There is no syntax change in the way we use it, right? Just the keywords union and structure, that's all. Other than that, you can do anything with a structure that you can do with a union. Okay, so anyone has any questions or queries on this? You can ask me. We are almost nearing the end of your syllabus. We have covered so many concepts this semester, okay? And we're almost very close to the end of your, programming fundamental syllabus. Probably in another 3, 4, 5 classes, we can finish off, your syllabus would be done, right? However, what I have planned is that once I finish your syllabus, probably this week, by the end of this week or early next week, I should be done with your syllabus, and then I'm going to give you first the materials of all the pending chapters that we have actually studied. My first priority will be to give you all the materials, right? I think from array onwards, I have not shared any materials with you. I will share that with you, right? After that, I will be giving you a lot of programs to do. Okay, so rather than having classes, I'm going to start giving you materials, and I'm going to start giving you programs which you can practice once we finish our syllabus. So we have just one chapter left in your programming fundamental syllabus. You can go through, have a look at your syllabus, and see if there is anything that we missed out. I am not very sure. All of you have BSc syllabus with you, BSc and BCA syllabus. Go check out your syllabus and see whatever is mentioned in the syllabus, have I taught you or not. I have one chapter left, which is file handling, right? And we can cover that in 4 or 5 classes. Okay, so with that, people have already started giving their attendance. So you can go ahead and give your attendance. And once you're done, you can leave.